Today I am going to discuss about increasing and decreasing function. Decreasing function. Increasing and decreasing function. So let us take a graph. Here you see I'm just taking a graph, just a graph. The graph is something like this. The graph is something like this. Let it be y equal to fx. Let it be y equal to fx. So at the top here, from here we find that the graph is increasing, it is ascending, and from this top it is descending. So in order to find an interval, means we have before to find the graph is increasing or decreasing, we have to give the interval between which it is increasing and the interval between which it is decreasing. There are also some graphs where it is always increasing or always decreasing. There are some graph, but yet we have to give an interval. Within the interval the graph is increasing, and within that some interval the graph will be decreasing. Now this is the point where if you draw a tangent here, the tangent will become parallel to x-axis, and here this tangent at this point, let this point be x is equal to c. At this point the derivative of this c will be 0. That is, your tan theta becomes 0 parallel to x-axis, so your derivative, that is the slope of the tangent will be 0. Now this is this point c. This point c is called the critical point, is called the critical point. This point c is called the critical point. It is called the critical point. Now from this graph we see that here uh, here if we move this side, if we move from this is 0, if we move this side, what do we find? We find that here, let this be x1 and this be x2. So here we find that x2 is greater than x1, and this is fx1, this is fx1, and this is fx2. At the same time we find that fx2 is greater than fx1. So we can say that here the graph is increasing. Now in this side, if you see, the graph is increasing in this side. Now in this side, let this be x3 and this be x4. So this will be fx3 and this will be fx4. So here you find that on this side, this x4 is greater than x3, but your fx3 is greater than fx4. So in this side the graph is increasing. The graph is increasing. But it's in this side the graph is decreasing. So we find that within these two intervals the graph is increasing, and within these two intervals the graph is decreasing. In order to determine the point of intervals uh, where the graph is increasing or the graph is decreasing, first of all what we have to do in order to find the interval, first of all we have to find the critical point, that is f dash c is equal to 0. We have to find the critical point, and when we find the critical point, then we have to first of all find the critical point where the slope is your 0, where the slope is 0. When we find the critical point, then the portion where f dash 6, the interval where f dash x is greater than 0, the portion where f dash x is greater than 0, then it is that portion is increasing, that portion is increasing portion, and where f dash x is less than 0, it is the portion is decreasing portion, the portion is decreasing portion. So here what we do, we find in order to find the intervals, we first of all we have to find out the critical point where the slope is your mm, parallel to x-axis, where the slope is 0. First of all you have to find the critical point, and on the side where f dash x is greater than 0, that side is increasing portion, and on the side where it is less than 0, then that portion is a decreasing portion. Now if your decreasing portion, so how to determine the intervals, how to determine the intervals? This is an NCRT problem which I am going to take. This is an NCRT problem, NCRT textbook problem, and here we have to find the intervals, we have to find the interval. Now the question is, that is x square plus 2x minus 5. We have to find the interval. Now you will see that first you will find here that first of all I have to find out f dash x, that is 2x plus 2. Now we have to determine the critical point, the point where f dash x becomes 0, that is parallel to the your slope of the tangent becomes parallel to x-axis, slope of the tangent it becomes parallel to x-axis, that point we have to determine. So 2x plus 2 equal to 0, and 2x is equal to minus 2, so x is equal to minus 1. This is the critical point where your slope is parallel to x-axis. Now to explain it better, let me draw a graph of it. What will be the graph of this what will be the graph of this x square, the function given to you? What will be the graph of it? Now let me explain, draw the graph of it. To draw the graph of it, let us take this, we have to draw the graph of it. Let me draw the graph. So y is equal to x square plus 2x plus 5. Now let me draw the graph for x and y. For this x is equal to 0, your value is 5, and for x is equal to 1, your value becomes 1 plus 2 3. 3, oh sorry, this is minus 5, this is minus 5. So 1 plus 2 3, 3 minus 5, that is minus 2. Again let me take minus 1. For minus 1 it will be minus 1 square 1 minus 2. So minus 2, this will be minus 2, minus 7 plus 1 minus 6. Now again let me take 2. If we take 2, 4, 4, 4 plus 4, it becomes 8. 8 minus 3, it will be 8 minus 5, it will be 3. And now let me take minus 2, so this will be 4. 4 minus 4, 4 plus 4 minus 4 will be 0, and this will be minus 5. So let me draw a graph of it. What do you find? We find that when it is a 0, it is minus 5, somewhere like this, minus 5. And when it is 1, it will be 2, minus 2, somewhere here like this, minus 2. This is the minus 2 point, somewhere like this. And when it is minus 1, it is minus 6, somewhere here, you can see this is minus 6, minus 6. This is the point. And then when y is equal to 2, it is y is equal to 2, it is 3, 1 2 3, somewhere like this, 2, and then y is equal to 3, somewhere like this. Here I can say somewhere like this, 1 2 and 3, somewhere like this. And when y is equal to minus 2, y is equal to minus 2, it is again minus 5 here, minus for minus 2, and this is for 1, this is for 2, this is somewhere say minus 5, is somewhere like this. Now if we draw a graph, it comes out like this. See, it comes out like this. Graph is somewhat like this. It is the shape of a parabola. It is the shape of a parabola. Shape of a parabola. Now here you find at x is equal to minus 1. Here your slope is this slope of the tangent. It is parallel to x-axis. This is parallel to x-axis, slope of the tangent. It is parallel to x-axis, and this slope of the tangent here, f dash, this at f dash minus 1, it is 0. This is the, therefore your critical point C is minus 1. Now here you see this side you can take any value, that is from minus 1 to this side you take any value like, suppose I let me take 0. So when we take 0, your x is equal to 0, we find that when we place it in f dash 0, this becomes 2 into 0 plus 2, this is 2. This is what? This is greater than 0. Here we find that it is greater than 0. Now again if we take some other value, you say if I take 0, then if I take 1, then your 1, then f dash 1, this will be 2 into 1 plus 2, that is 4, this is greater than 0. So here we find that here f dash x, for the value of f dash x we are getting greater than 0. So this side this side you see, this is the increasing portion, this is the increasing portion. Here you side see, this is the increasing portion. And if you take this side, this is the increasing portion, this is the increasing portion of the graph. And if you take any number this side value, say let me take say minus 2, so f minus 2, f dash minus 2, this is equal to 2 into minus 2 plus 2, that is minus 4 plus 2, that is minus 2, and this is less than 0. If you take f dash minus 3, you will get 2 into minus 3 plus 2, that is equal to minus 6 plus 2, that is minus 4 less than 0. So this side you find that this is the decreasing portion. So we can conclude here. So we can conclude that. So we can come to a conclusion. That within this interval minus 1 to say infinity, open interval, this is increasing, this graph is increasing, and minus infinity to minus 1, this is the decreasing portion. This is the decreasing portion. So this is what about in order to determine the interval, how to determine the interval. This is the actual procedure, but a shortcut has been done for it. An algorithm has been made in order to determine the intervals. Algorithm has been made is for the students, so that it becomes easy for you to determine the interval. For this we draw a number line. This is the number line. and here this is the minus 1, this is plus infinity to minus infinity. Here this side plus, it starts from plus minus. So if f dash x, for increasing f dash, for increasing this f dash x must be greater than 0. To be greater than 0, this will be minus 1 to infinity, the positive side, greater than 0. This is increasing, and for the decreasing portion, this will be from minus infinity, the negative side, minus infinity to minus 1. This is the decreasing part. This is the decreasing interval. Here the graph is decreasing and here the graph is increasing. This is an algorithm which has been made for the students. Algorithm which has been made, it becomes easier for you to solve the intervals. To solve the intervals. So I think so it is clear to you how to determine the intervals. How to determine the intervals. What is why. Now I want to tell one more thing. Why this if f dash x is greater than 0, then it is increasing. It is an increasing function within the interval. And if f dash x is less than 0, then it is a decreasing function. Why we have taken this as increasing or decreasing? To explain it, let me draw again the graph of it. Let me draw the graph of it. Let me draw the graph. Say you see, let this be a graph. Let this be a graph. Here say y is equal to fx. This be a sum of graph x o x dash, and here this is y o y dash. What do we find here at this point? At the top, at this point here, suppose x is equal to c. Here we find the slope is parallel to x-axis. Here we find the slope is parallel to x-axis. Slope is parallel to x-axis. Here your f dash c is 0. Now if you take any point here, let me take this point, you draw a tangent here. At this point you draw a tangent here. So again, you let me extend this x-axis. X dash. Again at this point you draw another tangent at this point. Let me draw a tangent at this another point. Let this be the tangent. So here we see that this is theta 1 and this is theta 2. Now this theta 2, this is theta 2 and this is theta 1. So here there is one thing there is one thing, that is theta 1. As we are moving this side, as we are moving this side, what do we find here? That tan theta 2, here this is the slope. So tan theta 2, now in anti-clockwise direction it is okay, everything is okay. Now the problem here is that let me change little bit. Let me change the diagram little bit. So let us take like this. So let this be the graph. At this point here your tangent is this is x is equal to c. Here your f dash c is your 0. That means slope of this tangent is parallel to x-axis. Your slope of the tangent is parallel to x-axis. Your slope is parallel to x-axis. Now you take a point here and you draw a tangent at this point. You draw a tangent at this point. Here this is theta 1, and on the other side you also take a point here and you draw a tangent here. You draw a tangent here. Let me extend it. You draw a tangent here. So theta 2. Here you see, here you can see that theta 1 is an acute angle, acute angle. It is an ac- it is an acute angle. It's an acute angle. So your so it is in first quadrant. It is in first quadrant. It is in first quadrant. Quadrant, and therefore your tan theta 1 will be greater than 0, whereas theta 2 is an obtuse angle, angle, and it is between 0 and 180 degrees, so it is in second quadrant. It is in second quadrant. Second quadrant. It is in second quadrant. So here your tan theta 2 will be less than 0. You will give negative value because tan theta is negative in the second quadrant. So here you find that, what do we find here? Here we find that f dash x is greater than 0, and here we find that f dash x is less than 0. Here f dash x, you see the slope, it is we are moving upward, this is moving upward, and here we see that we are moving downward, so when we are moving upward, that means it is increasing, and when we are moving downward, that means it is decreasing. It is decreasing. So here we see that you here again, again you can therefore we have considered that f dash x, when f dash x is greater than 0, it is increasing, and when f dash x is less than 0, it is decreasing, so here we can, that means in this side we are ascending upward, and in this side we are descending upward. uh, in, in terms of f dash x, uh, we can say that higher you go above, higher you go upward, your the value of f dash x go on decreasing till you reach to 0. That means mm, that means suppose when you throw a ball, upward, when you are throwing a ball upward, what happens? Your velocity gradually decreases, and at this point your velocity becomes 0, velocity decreases. So that means if you draw a tangent here at this point, if you draw a tangent at this point, let me draw it again for you. Say uh, this uh, this is the graph. Suppose velocity time graph. You can take a velocity time graph, and if you are throwing a ball upward, what happens? It will move in a parabola path. If you are throwing a ball in some angle in upward direction, what happens? It will move in a upward direction, and at this point your velocity will be 0. That means at this point your tangent, slope of the tangent will be parallel to the x-axis. This will be parallel to the x-axis. Here your f dash x will be 0. Now here if you take a point here, draw a slope here, you draw a slope here. What do you, and again you take another point here, you draw a slope again here, this side. This is a slope at this point, and this is the slope, you draw a slope here. What do you find? That as we go on upward, your velocity goes on decreasing. Similar is the effect with f dash x. So when at this point here theta let be theta 1 and this be theta 2. Since theta 1 is greater than theta 2, since theta 1 is greater than theta 2, and your tan function is an increasing function, your tan function is increasing function, so tan theta 1 is greater than tan theta 2. So here your f dash say x1, your f dash x1 is greater than f dash x2. This will be the effect when the graph is increasing, because as you go up, what happens, your velocity goes on decreasing till it reaches this, and as we come down, your velocity starts increasing. So in the other side, if you see on the other side, if you take a point here you see here the slope is this, and again you take a point here, your slope will be this. So here you find that this angle is greater than this angle, and since it is in second quadrant, so is in second quadrant, so tan theta will be negative, so this will have a higher negative value than this will have a higher negative value than this will have a higher negative value than this. So from this higher the negative, lower is the value. So this higher is this negative value, so it is lower than the value of this, so this velocity is greater than this. So same thing happens in with f dash x. Here since this your same thing happens with f dash x also. So what I want to tell you that what I want to tell you from this graph, that why f dash x greater than 0 is taken as increasing, and f dash x less than 0 is taken as decreasing. This I want to explain you. So if f dash x, so the conclusion is that if f dash x is greater than 0, then it is an in this interval it is an increasing, it is in the graph is increasing, and if f dash x is less than 0, then it is decreasing. Now let me take another example. This is an NCERT problem. Let me take another example that is let me take another example, that is minus 2x cube minus 2x cube minus 9x square minus 12x plus 1. Let me take another example. Let me take another example. Take another. So first of all, I have to find the f dash x, the critical point where it is 0. I have to first of all determine the critical point. So this becomes minus 6x square and minus 9 to the 18x and then minus 12. And in order to determine the critical value, is minus 6x square minus 18x minus 12. This will be equal to, you have to make 0. So here we can take minus 6 common, x square minus 6 3 the 18 plus 3x plus 2 equal to 0. So here x square plus 3x plus 2 equal to 0. So x square plus 2x plus x plus 2 equal to 0. So x common, x plus 1 and plus 1 common, x plus 2 equal to 0. So x sorry, this is x plus 2, x plus 1 and x plus 2 is equal to 0. So x is equal to minus 1 and x is equal to minus 2. So here the critical points are, say the critical points are here, these are minus 1 and minus 2. Here the critical points are minus 1, this is plus infinity, and this is minus infinity. So now here you see this is the number line, minus 1 minus 2 plus minus plus. So here plus portion, this is the increasing portion, and this portion is the decreasing portion, and this is the increasing portion. But since already your f dash x is negative, here f dash x is negative, so the sign will change. Instead of plus it will become minus. So this portion will be strictly decreasing portion. This portion will be strictly decreasing portion. And this again the minus will change. Minus will become plus, and this portion minus 1 to minus 2, sorry, minus 1 to minus 2, this will be strictly increasing portion. The sign will change. And this portion, this is plus, this will become sign will change, it will be minus. So this portion will be strictly decreasing. In the previous questions, it was this x square plus 2x minus 5. F dash x was this. This was the your critical point. Here you can say I have written in the previous is increasing. You can also say it is a strictly increasing portion. This is the strictly increasing portion, and this is the strictly decreasing portion. Now I think so you all have understood it, how to find the intervals. So